Hello everyone, we are Team 16. The idea behind our project was to develop a cost-efficient water quality monitoring buoy. Our buoy has the autonomous feature to power on and off to collect and store data with sensors for examination.
In our initial research phase, we used FIU's concept development guidelines to create different concept designs. We used the following concept diagram where three major factors were discussed. They include the sensor types to be used, the main power source, and the structure of the floating device. With that, we created three different alternatives of which we could pick from. Taking into consideration the overall cost, power consumption, safety, and ease of use, we came to decide that option 3 was the best alternative. Option 3 was chosen as the best alternative. However, a major change that occurred over the course of Senior Design 2 was the removal of the communication module, and instead we opted to store the data to be collected when needed, as constant use of communication module could increase power consumption. Our prototype was to look like the render shown here. However, due to some unfortunate setbacks related to the 3D printer that was set to print the bottom of the float, and the possible late arrival of the clear dome, we were unable to deliver the iteration of the buoy. And so, our current prototype is a functional, but it is not our preferred final prototype. We tried to make our makeshift prototype resemble the rendering as much as possible. And with that, we created our prototype. In our final block diagram, we have the Raspberry Pi as the main processing unit that handles all devices needed to collect data. We also have an SD card with the Raspbian operating system installed and where all our Python scripts are stored. We also use the SD card as a storage unit for the data collected. Along with that, we have the PyJuice module and battery that will aid with the autonomous on and off feature of the system, as the PyJuice hat does have an RTC module unlike the Raspberry Pi. We also have solar panels that will power the PyJuice hat to charge the battery during the day. We have a total of 3 sensors which collect temperature, turbidity, and conductivity data. The Raspberry Pi communicates in 3 different ways with the sensors being used. With the temperature sensor, it communicates using a single pin, also known as a one-wire communication. The conductivity sensor communicates through a UART connection, and because the Raspberry Pi lacks an integrated A&D converter for turbidity sensor, we use the Metro Mini microcontroller to relay the information via USB. Once the data is collected, it will then be stored in a text file that can later be retrieved when needed. For our demonstration, we would like to demonstrate the process of data collection. As we can see, when the program is started, it will print start. Once started, it will collect the data and store it in a text file. It is also set to indicate when the program is done, and the data can then be seen in a text file. This program is part of an autonomous feature which features an on and off sequence that occurs every hour to collect samples. The process of data collection occurs on boot, and once a small delay happens, it will then be prompted to shut down to conserve power and continue the cycle.